Hello lovely learners, how are you all doing today? I hope you are doing great. We thank God for another opportunity for us to meet and continue with our virtual learning. Now in the olden days, our people used to work a lot in order to earn a living. Especially when you want to travel, you used to walk a mile before you can reach your destination. We thank God and thank the scientists for introducing more complex or complicated machines such as tractors, cars, and the rest to ease transportation or to make transportation possible. Today we continue with our virtual learning and on the topic machines. I therefore urge you to pay attention so that by the end of today's lesson, you should be able to classify levers under first class, second class, and the third class levers. And two, you should be able to explain the following terms under machines. That is work or work done, energy and power. And last but not least, you should be able to explain the terms compound or complex machine as I've already mentioned. So these are our objectives for the day's lesson. I wish you the best in this lesson. Now, just take a short test and let me see how you were able to cope with the previous lessons. In our previous lessons, we talked about the classes or classification of levers. We talked a little about the first class, the second class, and the third class levers. As the acronym goes, we have the FLEE. That is for first class levers. The fulcrum or the pivot is positioned between the load and the effort. And in the second class levers, we have the load being positioned in between the fulcrum and the effort. In the last class of lever, we have the effort positioned in between the fulcrum and the load. So this is how we can classify various levers or various simple machines under the following classes. Now let's look at the following examples and try and classify them under the three classes of levers for me quickly. Now the first one is crowbar. This is a crowbar. In case you don't know what a crowbar is, this is a crowbar which is mostly used by carpenters for removing nails in thick woods or boards. That is a crowbar. So just examine where do you think the pivot will be, the fulcrum will be, and the load will be. But remember that the load is wherever you are going to position the item that you are going to work on. For example, if this is the nail that you want to remove from a piece of wood, for instance, we have this, you can use this side to remove the nail like this. So this side becomes the load. This side is the load, and where the turning will take effect or will take place is the fulcrum or the pivot. And remember, where you are handling is the effort, because you are applying a force over there, so that place becomes the effort or the force. You can either use this side as well, and we are going to have the same type of a lever here, that is the crowbar. We also have the claw hammer. This is a claw hammer. Remember this one, this where you are going to put your load or the nail that is to be removed from a piece of wood or board like this, and this is where the turning will take effect, and this is where you are going to apply your effort. That is another simple machine, which is the claw hammer. Now we have this, which you all know is not a scissors. This is a garden shears for trimming hedges, or is used by the gardeners. Now, where do you think this simple lever will be classified? We have the effort, we have the load where you are going to put or the flower that you are going to cut or trim. This side becomes your load, and where the turning take effect is the effort, and where you are holding or where I'm holding is the effort. So we have the pivot or the fulcrum here, we have the load, and we have the effort. So we know the positions of the various parts of the lever. Now quickly classify the rest for me. We have wheelbarrow, we have a table knife, we have the human forearm, we have a pair of compasses, and we have a bottle opener. Now quickly draw a simple table and arrange the following for me. Okay, now let's continue. I know most of you are very fast, and therefore I'm sure you are done wherever you are. So let's look at the ideal solution from here. Now for the first class levers, you can see that if you have the first class, second class levers, and the third class levers or class, you can see that looking at the positions of the parts of the lever, you can see that the crowbar is under first class. We have the crowbar here under first class lever. We have the claw hammer because you can see that they have similar parts. So claw hammer is under first class levers. Then we have the garden shears. Garden shears is under first class lever. And the second class lever, we can see that we have the wheelbarrow, which is not here, but you can picture it. We have the wheelbarrow, which is under second class lever. And we also have the bottle opener under second class levers. And the third class levers, we have pair of compasses. I hope you know the functions of compasses. Pair of compasses, you can see this is where the turning takes place. That is the fulcrum or the pivot. We have the load where the pencil is, and where you are handling or where you are going to hold to construct your circle is the effort. We have similar compass here. We have this one also here. This is where the turning takes place, and therefore this side is also known as the fulcrum or the pivot. And we have this side where you are going to handle or hold. That is the effort, where you are going to apply the force. And this is where the load is going to be placed. As you can see, the chalk is here. This is used to construct circle. That is the function of the compass, and this one also is under third class lever. We have the table knife, which is also under third class lever. We have the human forearm. Which is also classified under third class lever. I hope you had everything correct. Thank you very much. And let's proceed to our next core point or sub-topic. Now under machines, we have the following terms. Let's look at the following terms quickly. We have what we call work or work done. Now work is said to be done when force is applied to move an object through a distance. When force is applied to move an object through a distance, that is work done. So for example, if this crowbar here, if I move it or push it from this side to this side, work has been done. If I move it from here to here, work has been done. Now when you are sleeping, is work done? Is any work done when you are sleeping? You can ask yourself that question. What if you are eating? Is work being done when eating? Okay. So work is said to be done when a force is applied to move an object through a distance in the direction of the force. Now the SI unit for force is joules, and the abbreviated is big J, so that is work done for you. Now work done can also be given as force, it can also be given as mass times gravity times height. And this type of work done is potential energy. When a body is at a position and when the object is falling from a height, you consider the gravity, that is acceleration due to the gravity, and the mass of the object as well as the height in which the object is positioned. So that is the work done for you. Now we have another term under work done, which is energy, under machines, which is energy. Energy is the ability to do work. The ability to do work is considered energy, and the SI unit is joules. We also have power under machines. And power is the rate at which work is done. The rate at which work is done. And mathematically, power is expressed as work done over time. Because when you are doing something, you consider the time. And that is what the power for you. And the SI unit is also wattage or the watt. That is work power. And the unit is wattage. Now I've already mentioned about complex or compound machines. Compound machines, they are machines made up of two or more of simple machines, and they are mostly uses engines to operate. For example, we have the tractor, we have bicycle. Though the bicycle no engine, but it's made up of two or more of the simple machines. We have cars, which you know is operated by engines. We have the mower, we also have sewing machine, and the rest that you can mention. These are compound machines, and as I said earlier on, compound or complex machines make work more easier. So I think this is where time will allow us to end our lesson for today, and I hope to come your way next time. God bless you and continue to revise your notes. Bye bye.